This is the, turning to the page 1 of 4 of the spreadsheet. The title of the spread is ARC 1104, average lambda 2025 TOU analysis. This is the first of 2 pages that contains the hourly summary by month for the company's system lambda, which is basically the marginal cost of their generators. 2 things I wanted to point out in this on page 1 and 2. First is that the system lambda is not, it may be the marginal cost of the company's resources, but it's not the marginal cost of energy that they're actually using to meet their demand at that point in time. So Mr. Elliott is, if he was basing his numbers on strictly the system cost of their own generating fleet, he's overlooking the data that's on page 3 of this same exhibit. So if you scroll down to page 3, here you can see the purchases that the company is making. The top is based on real-time purchases, and the bottom is based on total purchases, including real-time. And 2 things to note, if you compare the relative costs of the purchases and the system lambda, is first, the costs of the purchases are substantially higher. And in fact, in the summertime, you can see there, looking at the real-time purchases in July, the column that says average purchase total, which is equal to basically the dollars of purchases divided by the megawatts of purchases, is $127 a megawatt hour. That's basically 3 times the variable cost that the company is claiming that its own fleet is able to do. And I'm sorry, 4 times the cost that it is actually using to generate its own energy. But the reason that the company is purchasing energy in the wholesale market is because it needs to. It's not choosing to spend $127 per megawatt hour just because. It's doing that because it needs to buy additional resources in order to meet its peak load during those summer months. The bottom set of numbers here is the total purchases, including real time. And you can see here, the first column, megawatt purchased, is much, much larger. I did some math on these, and in the winter months, the company is buying between 300 and 400 megawatt hours every hour. So basically 300 to 400 megawatts is included in this schedule every hour of the month in this. In the summertime, that number goes up between 500 and 700 megawatts. So the company is buying substantial amounts of power, either from the wholesale market or through different mechanisms that they're not their own generation. And as you can see, once again, in the average purchase total, they are doing that at costs that are substantially higher than their own system lambda. Now, this data here, unfortunately, does not show the hourly breakdown. We did ask the company to provide this information on an hourly basis, and the company said it was not able to. So had I had this information, I would have done some additional analysis. And based on the work I've done in the APS case, I can tell you that it is almost certainly that the afternoon peak hours in the summer are substantially higher than the midday hours in the summer. And so the differential between these prices is much larger than what the company is representing just by using its system lambda. I think that's all I have on the Mr. Elliott comments.